Whoa, whoa. Uh-oh. What's up, all you calc disciples? Coach Dell here hitting you with that Friday foghorn for my A-Day kids. B-Day, get ready to rock and roll on the Monday. Madness, all right? We're here jumping into the next thing that we're going to talk about. And it's something called an integral. Here we go. All right. So we went from derivatives and deriving functions, and now we are rolling into the big topic for the second half of the year, integrals. The integral is the opposite of a derivative. So pretend we took the derivative, erase all the work, and now we're starting with the derivative and going back to the original function. That's right, suckers. Here we go. So just like for a derivative, we've ingrained in our brain, Kolenko, I hope you're listening. We've ingrained for derivatives that it's the slope of a tangent line. For an integral, this is important. It's the function for the area under a curve. Area under a curve. Integral. Area under a curve. There's two types that we're going to be looking at. A definite integral and an indefinite integral. Definite means it's bounded. We'll be able to get a number for the area. Indefinite means that it is not bounded. We will not be able to get a designated number for the area. We will just be getting a function for it, similar to a derivative. When we get a value to plug in, we get the slope. When we don't, we just get the equation. So here we go. For integrals, characteristics, think an opposite of the derivative, and it gives us the original function. All right, so we're working backwards now. The notation for an integral is this stretched out S looking thing. That means the integral of, that's the derivative of a function. Remember, we said we're starting with the derivative, working backwards. And this dx means with respect to x. So the integral of a function with respect to x. All right? John, that's a prime, not a 1. All right, f prime. So here we go. The whole reason we do this with integrals, all right, if we were looking for the area under a curve, what we would naturally try to do is fit as many shapes within this area, this location, and then take all of their areas, like take their dimensions, right? Find out what the area is, and then add them all up. However, here's what happens. The most logical shape that we could use, and the calc guides have come up with, are rectangles. Now, here's what happens. If we draw a rectangle, it's either going to go a little bit above, and we'll have a little bit extra on that curve, or a little bit below, and we're going to be a little bit under from our curve. So the calc guides are like, yo, if we do the upper limit, all right, the integral with those rectangles going over, and the integrals with the rectangles going under. And then we average them, and then we'll get our limit. That sounds like a lot of work. So the calc guides, after they had got their friends together, had some calc dinies, some calc tails, they sat down, they came up with the integral rules. Similar to derivative rules, all right? So here we go. We're rolling on this journey. I got you. That's right. I'm in my cutoff right now. Johnson cutoff, bringing you some life. Here we go. Shout out. Reggie, you want to say hi to all the calc kids? All right. He's helping us crunch some numbers here, people. Here we go. The first rule. Integrating. All right, integrals with adding and subtracting. All right, just like we started with derivatives, with the power rule, we're doing the same thing here with integrals. Power rule, exponents. So this stuff doesn't change. We still don't want fractions. We still don't want radicals. We don't want parentheses. We love exponents. All right? When we get to the trig functions later down the road, we want to make it look like a trig function we could take the integral of based off of our cheat sheet. All right? We ain't getting there today, so don't worry about that. Brains will blow up. Here is one of the most important things when integrating on an indefinite integral like we're going to be doing. We're going to be integrating every part just like we did when we derived. But this is important. Our boy, C, has to get added at the end. Now you'll see when we do an example. Now I'm telling you our boy C because that substitutes for a constant that could potentially have been in the original equation. Later down the road, we find out what that constant value is because if you remember, when you take the derivative of a constant, it goes away. It turns into 0. All right? So we got to add C. You got to add our boy Carlos. Don't forget Carlos. When we integrate, Carlos has to be at the party. All right? Don't forget him. So here we go. Our power rule. Boom. This just pumps me up right here. Don't freak out, Coach K. We're all good. Coach K, we're all good. All right, here we go. So this is the integral of a function being raised to some exponent, okay, with respect to x. What we're going to do when we integrate, we're going to add 1 to the exponent and put the whole thing under the new exponent. So backtrack. When we took the derivative, we would exponent to the front, multiply, take 1 away, integral's the opposite. Dividing by the new and adding 1 to it. Don't forget Carlos. Here we go. Let's take a look at the example. Now, what we're looking at here, this is all great. We got all exponents, no radicals, no fractions. We're solid. Here we go. The integral of this function with respect to x. We don't got to worry about this. We're focusing here, integrating this. All right? So, we're looking at each part. Each of those x's are what we're focused on. Now keep in mind, there's no exponent here. It's like there's an imaginary 1. All right? For each part, we're adding 1, putting it over the new exponent. These constants are staying. All right? So here we go. Reggie. Hey! My dog just tearing the house apart, guys. So here we go. Focusing on the variable. Adding 1 makes it x to the 5th over the new exponent, 5. So the x to the 4th will integrate to x to the 5th over 5. 2, constant stays. X squared. Add 1, put it over the new. x squared will become x to the third over 3. The negative 3 is staying. The x to the first, add 1. Put it over the new. X squared over 2. So x to the first becomes x squared over 2. That constant's in the front. So now, when we all finished, add Carlos. Don't forget him. Constant value. We don't know what it is yet. We will later on. So, for us, now we got to reduce everything. These 3's will cancel. These 2's will cancel. The 2 over 5, right? 2, and we got the 5 in the denominator. We could just write that as 2 over 5, x to the 5th. Or 2/5 x to the 5th. This portion will reduce to negative x to the 3rd. This portion will reduce to plus x squared plus Carlos. So this function, if we were given a boundary and numbers, we would be able to find the area under this curve function within a certain boundary. Okay? Using that equation. It's coming down the road. Here we go. Let's look at another one. All right. Oh, I'm going to go right to there first. So here, fractions, no good. All right? We don't want this. So we got to think of a way to simplify this. You could either separate it, make it x to the 7th over x squared plus 3 over x squared. Then you could reduce these, bring the x squared up by making it a negative 2, right? Or you could do it where you just bring the x squared up by making it a negative exponent and then distributing it in. That's the way I'm choosing to do it. I think it's a little easier. When you distribute it in, advanced algebra, like terms, multiplication, add the exponents. So what ends up happening is it becomes x to the 5th plus 3x squared. All right? Now from here, we're good. All exponents, no fractions, we're good. So here we go. We're focusing yet again on each piece. Each of the x's. We're focusing on the x's. When we integrate, add 1, put it over the new. X to the 5th becomes x to the 6th over 6. Plus, careful with your signs now, people. Here we go. X to the negative 2nd. When we add 1, x to the negative 1st over negative 1. All right? Now we can simplify. We don't want radicals. We don't want negative exponents. We got to put it back in simplest form. So from here, this is going to stay. This becomes a negative 3 because you got 3 here times this negative 1 in the bottom makes this negative. And then we got to make that a positive exponent. So how could we do it? Move it to the denominator. So our final answer should be what we got here. X to the 6th over 6 minus 3 over x plus Carlos. All right? All right. Give it a go, all right? So here's the one I want you to try. All right? If you notice, we got radicals, we got things in the denominator. We got to rewrite it first. Okay? Positive exponents. no radicals. Don't get confused because of this, right? Whether we write it on the top or we write it next to it, it's the same thing. Focusing here. Add 1, put it over the new. Add 1, gotta be good with your fractions here, people. Put it over the new. Dividing by a fraction is the same thing as multiplying by the reciprocal. X to the negative fifth becomes x to the negative fourth over negative 4. The 4 is the constant. Now we got to reduce and simplify. Whoops. Multiplying fractions just becomes a negative 4 over 15. The 4 is reduced. Still a negative. We got to write this and this as a radical and a positive exponent. Final answer. This is the square root of x to the third, right? That just becomes 1 over x to the fourth. Now, next time, after we get some practice, we're going to be honing in on some different trig stuff. And at the bottom here, all right, for some reason, it's not letting me scroll down there, but the bottom here, and you'll see it on your notes that you'll get submitted. There we go. Now I think I got it. Boom. You have this function here. So we're not getting into the trig functions yet. Your homework is going to have one with a trig function on it. Obviously, if you're having trouble with it, it's all good. And we're going to talk about that more next class. Guys, make sure that you are submitting your assignments. Some of you, actually most of you, are doing a great job, but I'm still missing things and the grade book is changing. So make sure you're staying on. We're adapting and overcoming. See you guys soon.